Hi everyone. Today we're going to study pair of linear equations in two variables. Let's begin with linear equations in two variables. An equation which can be put in the form ax plus by plus c equals 0, where a, b, and c are real numbers, and a and b are not both 0, is called a linear equation in two variables x and y. Examples: 2x plus 3y equals 5. X minus 2y minus 3 equals 0. X minus 0y equals 2. In our third example here, we can simplify this as x equals 2. A solution of such an equation is a pair of values, one for x and the other for y, which makes the two sides of the equation equal. Example: show that the ordered pair 1, 2 is a solution to 2x plus 3y equals 8. For the solution, we substitute x equals 1 coming from this and y equals 2 coming from this to the equation and check the equality if satisfied. Our equation is 2x plus 3y equals 8. So it becomes 2 times 1 plus 3 times 2 equals 8. 2 times 1 is 2 plus 3 times 2 is 6. The sum 2 plus 6 is 8, which is equal to the value on the right, which is 8. Since the equation is satisfied, then the ordered pair 1, 2 is a solution to the given equation. Geometrically, a linear equation in two variables ax plus by plus c equals 0 represents a line on the plane. Now, each solution xy of a linear equation in two variables corresponds to a point on the line representing the equation, and vice versa. Let's go now to the pair of linear equations in two variables. The general form for a pair of linear equations in two variables x and y, we have a sub 1 x plus b sub 1 y plus c sub 1 equals 0. A sub 2 x plus b sub 2 y plus c sub 2 equals 0, where a sub 1, b sub 1, c sub 1, a sub 2, b sub 2, c sub 2 are all real numbers. A sub 1 square plus b sub 1 square not equal to 0. Also, a sub 2 square plus b sub 2 square not equal to 0. We have examples. This is the first example. The first pair is 2x plus 3y minus 7 equals 0, and 9x minus 2y plus 8 equals 0. Second pair, 5x equals y. Negative 7x plus 2y plus 3 equals 0. Another example, x plus y equals 7. 17 equals y. Geometrically, the pair of linear equations in two variables represents two straight lines on the plane. Given two lines in a plane, only one of the following three possibilities can happen. Number 1, the two lines will intersect at one point. As shown on this figure, this is the point of intersection. Second possibility, the two lines will not intersect. In this case, the lines are parallel. Here's an example of two parallel lines. Third possibility, the two lines will be coincident. This is an example of two lines that are coincident. We said that wherever the first line go, the second line go on that same path. Example 1. Akila goes to a fair with 20 rupees and wants to have rides on a giant wheel and play hoopla. The number of times she played hoopla is half the number of rides she had on the giant wheel. If each ride cost 3 rupees and a game of hoopla cost 4 rupees, how would you find out the number of rides she had and how many times she played hoopla? Represent this situation algebraically and graphically, or we say geometrically. First, we assign variables for the given. Let x be the number of giant wheel rides and let y be the number of hoopla played. The first condition on the problem is the number of times she played hoopla is half the number of rides she had on the giant wheel. We represent this in the equation as y equals 1/2 times x. This is our first equation. For the second condition, it says each ride cost 3 rupees and a game of hoopla cost 4 rupees for a total money of 20 rupees. We represent this as equation as 3x plus 4y equals 20. This is our second equation. Now, we're going to draw the two lines. As per the process, we're going to identify any 2 points of the line. Let's begin with the first one. This is our table. The first row is for the x, the second row for the y. For the y here, we will copy the equation down here. Then, we assign value for x. Let x be 0. We substitute the 0 to the x and we will get the value of y as 0. We assign x to be number 2. We substitute this 2 to the x in this equation. We will get the value of y as 1. So, for the first equation, the 2 points are 0, 0 and 2, 1. Let's go to the second equation. This is our table for the second equation. The first row is for the x, second row for the y. For the first row, we put here x. For the box here, we rearrange our equation 2 in such a way that the y variable is alone on the left side. So we have this y equals 20 minus 3x over 4. Then we assign x value to be 0. We substitute 0 to this equation, then we will get the value of y as 5. Next, we can assign 0 to y. Then we can solve for x and the value will be 20 over 3. Therefore, for the second line, the 2 points are 0, 5 and 20 over 3, 0. From here, we're going to connect the 2 points respectively to form the 2 lines. These are now the 2 lines. This is our line 1. This is the y equals x over 2. But when we simplify that, it is equal to x minus 2y equals 0. This is the second line. This is the line 3x plus 4y equals 20. Observe that the 2 lines intersect at the point 4, 2. In this case, we say that x equals 4 because this is the x coordinate. Therefore, Akila got 4 rides in giant wheel. And for the y equals 2. It means this 2 is the number of hoopla plays. And this is now the final answer. Example 2. Romila went to a stationery shop and purchased 2 pencils and 3 erasers for 9 rupees. Her friend Sonali saw the new variety of pencils and erasers with Romila, and she also bought 4 pencils and 6 erasers of the same kind for 18 rupees. Represent this situation algebraically and graphically. We let x be the cost of 1 pencil. We let y be the cost of 1 eraser. So the first condition is the Romila's purchase. Romila purchased 2 pencils and 3 erasers for 9 rupees. So we write here 2x plus 3y equals 9. This is now our equation 1. Second condition is Sonali's purchase. Sonali bought 4 pencils and 6 erasers for 18 rupees. So we write 4x plus 6y equals 18. This is our equation 2. Now let us draw the lines. Let's identify any 2 points of each of the equations. Let's begin with equation 1. This is our table. We have the row for x, we have the row for y. For the row for y, we rearrange our equation in such a way that y is alone on the left. So this is equal to 9 minus 2x over 3. Now we assign value for x. Let's say x equals 0. We substitute 0 to this equation. We can solve for y, and that is equal to 3. Also, we can assign 0 to y. Then we can solve for x, and the value will be 4.5. Therefore, the 2 points for the first line are 0, 3 and 4.5, 0. Let's go to the second equation. This is our table. Row for x, row for y. For the y formula, we rearrange our equation 2 in such a way that y is alone on the left. So we have 18 minus 4x over 6. Now we assign value 0 for the x. We substitute it here and we can solve for y, and the value is 3. Also, we can assign 3 for x. We substitute that value here. The value of y will be 1. Therefore, the 2 points for the second line are 0, 3 and 3, 1. Now, let us connect the points respectively to see the 2 lines. And here are the lines. This is the line for 2x plus 3y equals 9. This is the same line for 4x plus 6y equals 18. We can see that the 2 lines are coincident because the 2 equations are equivalent. Example 3. 2 rails are represented by the equations x plus 2y minus 4 equals 0 and 2x plus 4y minus 12 equals 0. Represent these equations geometrically. Let us draw the lines. Again, let us identify any 2 points of the lines. For the first equation, we have this table. We have the row for x, we have the row for y. For this equation here, we rearrange the first equation in such a way that y is alone on the left side. So we have y equals 4 minus x over 2. Then we assign 0 for x. We substitute 0 to this equation, and the value of y is 2. Also, we can assign 0 to y and we can solve for x. We substitute 0 to the y here and the x equals 4. So we have 2 points for this line. The points are 0, 2 and 4, 0. Next, our second equation. This is our table of values. Row for x, row for y. On this box, we rearrange our equation such that y is alone on the left. So we have y equals 12 minus 2x over 4. Now, let's assign 0 to x. We substitute 0 to this equation. The value of y is now 3. Next, we can assign 0 to y here. Then we solve for x. The value of x will be 6. Therefore, for the second line, the 2 points are 0, 3 and 6, 0. Now we are ready to plot the points and connect the corresponding points. Here are now the 2 lines. This is the first line, the x plus 2y minus 4 equals 0. This is the second line, 2x plus 4y minus 12 equals 0. We can see that the 2 lines are parallel. Hi everyone. Today we're going to study graphical method of solution of a pair of linear equations. Let's begin with pair of linear equations. We can summarize the behavior of lines representing a pair of linear equations in 2 variables and the existence of solutions as follows. First, the lines may intersect in a single point. We call this consistent pair of equations. In this case, the pair of equations has a unique solution. Second possibility, the lines may be parallel. We call this now inconsistent pair of equations. In this case, the equations have no solution. Third possibility, the lines may be coincident. We call them dependent pair of equations. In this case, the equations have infinitely many solutions. Let us see now the relationship of coefficients of pair of linear equations. Given the lines represented by the pair of equations, a sub 1x plus b sub 1y plus c sub 1 equals 0. Second equation is a sub 2x plus b sub 2y plus c sub 2 equals 0. These lines, we call them intersecting lines. If a sub 1 over a sub 2 is not equal to b sub 1 over b sub 2. Or we call them coincident lines. If a sub 1 over a sub 2 equals b sub 1 over b sub 2 equals c sub 1 over c sub 2. Third possibility, this pair of equations are parallel lines. If a sub 1 over a sub 2 equals b sub 1 over b sub 2 is not equal to c sub 1 over c sub 2. Example 1. Solve graphically. X plus 3y equals 6. 2x minus 3y equals 12. Let us identify any 2 points of each of the lines. Let's begin with the first equation. This is the table for the first equation. This is the row for x, this is the row for y. This equation here is the rearrangement of this equation 1, whereas y is isolated on the left. So we have here y equals 6 minus x over 3. Then we assign 0 for the x. We substitute 0 in this equation, then we will get the value of y as 2. Next, we can assign 0 for the y. We substitute the 0 to this y, then we will get the value of x as 6. So for the first equation, the 2 points are 0, 2 and 6, 0. Now, the second equation. This is our table. This is the row for x, this is the row for y. For the row for y, this equation here, simply we rearrange our equation 2 such that the variable y is alone on the left. So we have y equals 2x minus 12 over 3. Then we assign 0 for the x. We substitute the 0 to this equation. Then we will get the value of y as negative 4. Then we assign 3 for the x. We substitute this 3 to this equation. The value of y then will be negative 2. So the 2 points for the second equation are 0, negative 4, and 3, negative 2. Now let us plot the corresponding points and connect them with a line. These are now the 2 lines. This is the first line. This is the second line. Observe that the point B with coordinates 6, 0 is the point of intersection of the 2 lines. So the solution is x equals 6 and y equals 0. Also, the given pair of equations is consistent. Example 2. Find whether the following pair of equations has no solution, unique solution, or infinitely many solutions. 5x minus 8y plus 1 equals 0. This is the first equation. Second equation, 3x minus 24 over 5y plus 3 over 5 equals 0. Considering the second equation, we have fractions. Let us multiply the second equation by 5 over 3. So it becomes like this. The 3x times 5 over 3, we will get 5x. The negative 24 over 5y times 5 over 3, the answer is negative 8y. Plus, the 3 over 5 times 5 over 3 is positive 1 equals 0 times 5 over 3 is 0. Observing the resulting equation, this is the same as equation 1. Hence, the 2 lines are coincident. Therefore, equations 1 and 2 have infinitely many solutions. Example 3. Champa bought some pants and skirts. The number of skirts is 2 less than twice the number of pants purchased. Also, the number of skirts is 4 less than 4 times the number of pants purchased. How many pants and skirts did Champa buy? We let x to be the number of pants. We let y to be the number of skirts. For the first condition, it says the number of skirts is 2 less than twice the number of pants purchased. So we write here y equals 2x minus 2. Condition 2. The number of skirts is 4 less than 4 times the number of pants purchased. So we have y equals 4x minus 4. Then let us draw the lines. For the first line, we have this table. This is the row for x, this is the row for y. Let us assign values for x. Let's say 2. Let's substitute number 2 to this equation. then we can solve for y, and that is 2. Let's assign 0 for x. We substitute 0 to this equation, and the value of y will be negative 2. So the 2 points for the line 1 are 2, 2, and 0, negative 2. What about the second equation? This is the table. Row for x, row for y. Let us assign values for x. Let's say 0. We substitute 0 to this equation, we can get the value of y as negative 4. Also, we can assign 0 for the y. We substitute 0 to the y here, and the value of x is positive 1. Therefore, the 2 points for the second equation are 0, negative 4, and 1, 0. Let us now plot the points and connect. These are now the two lines. This is the first line, and this is the second line. Observe that the point Q, the 1, 0, is the point of intersection. Thus, Champa bought 1 pants and 0 skirts. Hi everyone, today we're going to study solution by substitution method. Given a pair of linear equations in two variables, here are the steps of substitution method. Step 1. Find the value of one variable, say y in terms of the other variable, that is x, from either equation, whichever is convenient. Step 2. Substitute this value of y in the other equation and reduce it to an equation in one variable, that is in terms of x, which can be solved. Step 3. Substitute the value of x or y obtained in step 2 in the equation used in step 1 to obtain the value of the other variable. Example 1. Solve by substitution method. X plus 3y equals 6, 2x minus 3y equals 12. Step 1. Find the value of one variable from one equation, whichever is convenient. Let this be our first equation. This is the second equation. Look at our first equation. We can isolate x in one side, meaning this positive 3y we will transpose to the right. So we have x equals 6 minus 3y. Then step 2. Substitute this value of x in terms of y in the other equation, meaning in equation 2, and reduce it to an equation in one variable. Our equation 2 is 2x minus 3y equals 12. This x here we will change by 6 minus 3y. So it becomes 2 times 6 minus 3y, then minus 3y equals 12. Simplifying, this 2 multiplied to 6 becomes 12. 2 times negative 3y is negative 6y. Then we copy this negative 3y equals 12. We combine this negative 6y and negative 3y. Also, the 12 here we will transpose to the right. So we have negative 9y equals 12 minus 12. The right side becomes 0. We solve for y. We divide this equation by negative 9. So the value of y equals 0. This is the value of our y. Then we go to step 3. Substitute the value of y, which is 0, obtained in step 2 in the equation used in step 1 to obtain the value of x. So our equation 1 is x plus 3y equals 6. We substitute the value y as 0 in here. So equation 1 becomes x plus 3 times 0 equals 6. 3 times 0 is simply 0. So the value of x is 6. This is the value of x. Example 2. Solve by substitution method. 2x plus 3y equals 9. 4x plus 6y equals 18. Step 1. Find the value of one variable from one equation, whichever is convenient. We assign this as the first equation. This is the second equation. Look at our first equation. Let us try to isolate y in one side, meaning this 2x we transpose to the right. It becomes negative. And then we divide the equation by 3, then y will be isolated. So equation 1 becomes y equals 9 minus 2x all over 3. Then step 2. Substitute this value of y in terms of x in the other equation, which is equation 2, and reduce it to an equation in one variable. So equation 2 is 4x plus 6y equals 18. The value of y here we will change in here. So equation 2 becomes 4x plus 6y. And 6y is now changed into 9 minus 2x all over 3. Then equals 18. The denominator 3 here can be cancelled out with the number 6. So it becomes 2. Then we multiply this 2 to the 9 and to the negative 2x. So we have 18 minus 4x. We copy this 4x down here and then equals 18. This 4x and negative 4x become 0. So we have 18 equals 18. Note that the variable x is cancelled out, but the equation is still true. 18 equals 18. If this is the case, the pair of linear equations has infinitely many solutions. Example 3. Solve by substitution method. X plus 2y minus 4 equals 0. 2x plus 4y minus 12 equals 0. Step 1. Find the value of one variable from one equation, whichever is convenient. This is our equation 1. This is the equation 2. Look at equation 1. We can isolate x and we can express this in terms of y, meaning this 2y and negative 4 we transpose to the right. So x equals 4 minus 2y. Then step 2. Substitute this value of x in terms of y in the other equation and reduce it to an equation in one variable. Our equation 2 is 2x plus 4y minus 12 equals 0. The value of x we will put here as 4 minus 2y. So equation 2 becomes 2 times the quantity 4 minus 2y. Then we copy plus 4y minus 12 equals 0. We simplify further. 2 times 4 is 8. 2 times negative 2y is negative 4y. Then plus 4y negative 12 equals 0. We simplify negative 4y plus 4y becomes 0. 8 minus 12 is negative 4 equals the right side value 0. Note that the variable y is cancelled out, but the equation is false. We see here negative 4 equals 0 is false. If this is the case, the pair of linear equations has no solution. Hi everyone. Today we're going to study solution by elimination method. Given a pair of linear equations in two variables, here are the steps of elimination method. Step 1. Multiply both the equations by some suitable non-zero constants to make the coefficients of one variable, either x or y, numerically equal. Step 2. Add or subtract one equation from the other so that one variable gets eliminated. Step 3. Solve the equation in one variable, x or y, so obtained, to get its value. Step 4. Substitute this value of x or y in either of the original equations to get the value of the other variable. Note that in step 2, if we obtain a true statement involving no variable, then the original pair of equations has infinitely many solutions. Also, still in step 2, if we obtain a false statement involving no variable, then the original pair of equations has no solution. Example 1. Solve by elimination method. X plus 3y equals 6. 2x minus 3y equals 12. Observe the coefficients of each of the variables. Let's copy our problem down here. Notice that the coefficients of y are numerically same, but of opposite signs. In this case, we can add the equations. When we add, the y variable will cancel out. Then x plus 2x is 3x equals 6 plus 12 is 18. And then we divide by 3. That is the coefficient of x. So that we will get the value of x equals 6. Because 18 divided by 3 is 6. So we have now the value of x. Now we substitute the derived value of x into any one of the equations. Let's say the first equation. This is x plus 3y equals 6. X becomes 6 plus 3y equals 6. This 6 here we transpose to the right. It becomes negative 6. Then the right side becomes 0. We divide the equation by 3 so that y equals 0. This is the value for y. So we are done with our problem. X equals 6, y equals 0. Example 2. Solve by elimination method. 2x plus 5y equals negative 8. 3x minus 4y equals 11. We copy our problem down here and let us observe the coefficients. Note that the coefficients of each of the variables are numerically different. In this case, we can decide which variable to eliminate. Let's say x. We're going to multiply equation 1 by coefficient of x in equation 2. That is the number 3. And vice versa. It means the first equation we multiply by 3. The second equation we multiply by 2. So the equations becomes like this. The first equation multiplied by 3 becomes 6x plus 15y equals negative 24. Second equation multiplied by 2, it becomes 6x minus 8y equals 22. Now we see that coefficients of x respectively are now numerically same. Therefore, we will subtract the equations. Remember, when we subtract, we need to change the sign of the terms of the second equation. The 6x here becomes negative, negative 8y becomes positive, the positive 22 becomes negative. Then we proceed to addition. 6x plus negative 6x is cancelled. 15y plus 8y is 23y. Negative 24 plus negative 22 is negative 46. And we want to get the value of y, we divide the equation by 23. So y equals negative 2. We have now the value of y. Then we substitute the value of y in any of the equations to get the value of x. Let's say equation 1. So 2x plus 5y equals negative 8 becomes 2x plus 5 times the negative 2 equals negative 8. 5 times negative 2 is negative 10. Then we transpose the negative 10 to the right. So 2x equals negative 8 plus 10. The right side becomes positive 2. To solve for x, we divide the equation by 2. So x equals positive 1. This is the value of x. Example 3. 5 years ago, Nuri was thrice as old as Sonu. 10 years later, Nuri will be twice as old as Sonu. How old are Nuri and Sonu? We let x to be Nuri's age. Y equals Sonu's age. Now the condition 1, 5 years ago, Nuri was thrice as old as Sonu. Let us represent the 5 years ago with respect to the age. So for Nuri, that is x minus 5. For Sonu, that is y minus 5. And it says, Nuri was thrice as old as Sonu. So to balance this, we will multiply 3 to Nuri's age. Then let us simplify the right side. 3 times y is 3y. 3 times negative 5 is negative 15. From here, we transpose 3y to the left. This negative 5 we transpose to the right. So we have x minus 3y equals negative 15 plus 5. Right side becomes negative 10. Now condition 2. 10 years later, Nuri will be twice as old as Sonu. Again, we represent the age of Nuri as x plus 10. The age of Sonu 10 years later will be y plus 10. It says again, Nuri will be twice as old as Sonu. So we multiply 2 to the age of Sonu. Then we simplify the right side. 2 times y is 2y. 2 times 10 is 20. Then this 2y we transpose to the left. The positive 10 we transpose to the right. So we have x minus 2y equals 20 minus 10. The right side becomes 10. So we have now the two equations. This is equation 1 here. This is equation 2. Let's put them together. Now we can see that coefficients of x are numerically same. We can subtract the equations. In doing so, we need to change the sign of the terms of the second equation. X becomes negative, negative 3y becomes positive, negative 10 becomes positive. Then we add. X plus negative x will cancel out. Negative 2y plus 3y is y. 10 plus 10 is 20. So this is the value of y. We said that y is Sonu's age. It means Sonu is 20 years old. Let us substitute the value of y in any of the equations. Let's say the first equation, the x minus 3y equals negative 10. So we substitute it here. X minus 3 times 20 equals negative 10. Negative 3 times 20 is negative 60. We transpose this negative 60 to the right. So x equals negative 10 plus 60. And the right side becomes 50. So x equals 50. In the beginning, we said that x is Nuri's age. So Nuri is 50 years old. Hi everyone. Today we're going to study solution by cross multiplication method. Given a pair of linear equations in two variables, here are the steps of cross multiplication method. Step 1. Write the given equations in the form a sub 1 x plus b sub 1 y plus c sub 1 equals 0. A sub 2x plus b sub 2y plus c sub 2 equals 0. In short, we're going to put the right side of the equations equal to 0. Step 2, we're going to rewrite these equations into this form. X over b sub 1 c sub 2 minus b sub 2 c sub 1 equals the variable y over c sub 1 times a sub 2 minus c sub 2 a sub 1 equals the constant 1 over a sub 1 b sub 2 minus a sub 2 b sub 1. In order for us to memorize this formula, this figure can help. Let us write the x, y, and the constant 1 in the first row. Then we arrange the coefficients and constants in this manner. This is the column for b, so b sub 1, b sub 2. This is the column for the constants, c sub 1, c sub 2. This is the column for a, the coefficients of x. So we have a sub 1, a sub 2. Another column for b, the coefficients of y. So b sub 1, b sub 2. Now look at this first fraction here. This is the fraction for x. So the x is on top and the denominator is the b sub 1 multiplied to c sub 2. Then minus b sub 2 times c sub 1. Next, the second fraction. This is for the y. Y will be in the numerator. In the denominator, we multiply c sub 1 times a sub 2 minus c sub 2 times a sub 1. And the last fraction. The constant 1 is the numerator. In the denominator, we multiply a sub 1 by b sub 2 minus a sub 2 times b sub 1. Then step 3, find x and y. Provided a sub 1 times b sub 2 minus a sub 2 times b sub 1 is not equal to 0. Now let us see the relationship of coefficients of pair of linear equations. Given the lines represented by the pair of equations, you can see here the right side are equated to 0. First condition, when the ratio a sub 1 over a sub 2 is not equal to the ratio b sub 1 over b sub 2. We get a unique solution. Second condition, when the ratio a sub 1 over a sub 2 equals b sub 1 over b sub 2 equals the ratio c sub 1 over c sub 2, there are infinitely many solutions. Third condition, when the ratio a sub 1 over a sub 2 equals b sub 1 over b sub 2 but not equal to the ratio c sub 1 over c sub 2, in here there is no solution. Example 1. From a bus stand in Bangalore, if we buy 2 tickets to Malleswaram and 3 tickets to Yeshwanthpur, the total cost is 46 rupees. But if we buy 3 tickets to Malleswaram and 5 tickets to Yeshwanthpur, the total cost is 74 rupees. Find the fares from the bus stand to Malleswaram and to Yeshwanthpur. We let x to be the fare going to Malleswaram. We let y will be the fare going to Yeshwanthpur. From the condition given, we can see that 2x plus 3y equals 46. Next condition, 3x plus 5y equals 74. For the step 1, we equate both equations to 0, meaning the constants 46 and 74 we transpose to the left, so it becomes like this. For step 2, we will now use our formula. Then we will substitute the corresponding values. So we have x all over 3 times negative 74 minus 5 times negative 46 equals, for the y fraction, y in the numerator over negative 46 times 3 minus negative 74 times 2 equals 1 over 2 times 5 minus 3 times 3. Simplifying the denominator, in the first fraction we have negative 222 plus 230 equals the middle fraction. The denominator now is negative 138 plus 148 equals third fraction 1 over 10 minus 9. Simplifying the denominators respectively, for the first fraction we have 8 equals second fraction, the denominator is 10 equals third fraction, denominator is 1. Now step 3, we will solve for x and y respectively. What we will do here, this first fraction x over 8 we equate to the third fraction 1 over 1. Now solving for y, we equate the y over 10 equals the third fraction 1 over 1. So it becomes like this, x over 8 equals 1 over 1, and for the y over 10 equals 1 over 1. When we cross multiply, we can solve for the values of x and y respectively. So the x equals 8 and y equals 10. In the beginning, we said that x is the fare going to Malleswaram and the y is the fare going to Yeshwanthpur. So we have 8 rupees, that is the fare to Malleswaram, and 10 rupees, that is the fare going to Yeshwanthpur. Example 2. For which values of p does the pair of equations given below has unique solution? We have 4x plus 4y plus 8 equals 0, 2x plus 2y plus 2 equals 0. For the given pair to have a unique solution, the ratio a sub 1 over a sub 2 should not be equal to b sub 1 over b sub 2. When we substitute the corresponding values, we have 4 over 2 should not be equal to p over 2. We can see here that we can multiply this inequality by 2. So, p should not be equal to 4. Therefore, for all values of p except 4, the given pair of equations will have a unique solution. Example 3. For what values of k will the following pair of linear equations have infinitely many solutions? Kx plus 3y minus the constant k minus 3 equals 0. 12x plus ky minus k equals 0. For a pair of linear equations to have infinitely many solutions, the ratio a sub 1 over a sub 2 equals b sub 1 over b sub 2 equals c sub 1 over c sub 2. Let us substitute the corresponding values from our given linear equations. So we have k over 12 equals 3 over k equals negative k plus 3 over negative k. We can see here we have three parts of equations. We have the left side, the middle part, and the right side. Let us equate the left side and the middle part, then we solve for k. So we write k over 12 equals 3 over k. When we cross multiply, we will have k squared equals 36. Then we take square root of both sides. So we will have two values of k as positive 6 and negative 6. Now let us equate the middle part and the right side. Then we will solve for k. 3 over k equals negative k plus 3 over negative k. When we cross multiply, we have this negative 3k equals negative k squared plus 3k. The right side members we transpose to the left side. This is positive 3k. When it is transposed, it becomes negative 3k to be combined with the negative 3k on the left. So we have now k squared minus 6k equals 0. We can factor out the common k. So we have k times the quantity k minus 6. When we equate each factor to 0, we will have two values of k. So k equals 0, also positive 6. We can see here, in the first condition, we have two values of k, positive 6 and negative 6. In the second condition, there are also two values of k, 0 and positive 6. Note that the positive 6 is a common solution to both conditions. Therefore, k equals 6 satisfies both the conditions. For this value, the pair of linear equations has infinitely many solutions. So our answer here, k equals 6. Hi everyone. Today we're going to study equations reducible to a pair of linear equations in two variables. In this video, we shall discuss the solution of such pairs of equations, which are not linear, but can be reduced to linear form by making some suitable substitutions. We now explain this process through some examples. Example 1. Solve the pair of equations 2 over x plus 3 over y equals 13. 5 over x minus 4 over y equals negative 2. First step here is to factor out the numerator respectively. In the first equation, we have 2 times 1 over x plus 3 times 1 over y. Second equation, 5 times 1 over x minus 4 times 1 over y. Then we let p equals 1 over x and q equals 1 over y. The equations becomes like this. 2p plus 3q equals 13. 5p minus 4q equals negative 2. Then let us solve using any method, the p and the q respectively. Let us solve this by elimination. We copy our equations in here. Now let us eliminate q. In our process, we multiply the first equation by the coefficient of q in the second equation, and vice versa. So it becomes like this. First equation times 4, second equation times 3. The first equation becomes 8p plus 12q equals 52. Second equation becomes 15p minus 12q equals negative 6. Now let us add. We can see here that the q variables has coefficients that are opposite signs. When we add now, the q variable is cancelled out. Then 8p plus 15p equals 23p equals 52 plus negative 6 is positive 46. From here, let us divide by 23, and the p-value is 2. Now we substitute this p-value to any of the equations. Let's say in the first equation, this 2p plus 3q equals 13 becomes 2 times 2 plus 3q equals 13. This 2 times 2 becomes 4 plus 3q equals 13. This 4 we transpose to the right. So we have like this, and the right side becomes 9. Now let's divide by 3. We will get the value of q as 3. We have now the values of p and q coming from these equations. But our original problem is here. Remember that we set p equals 1 over x and q equals 1 over y. Let us now solve for x and y respectively. Let's begin with p equals 1 over x. We substitute the value of p here, then we will solve for x. P is 2, so we have 2 equals 1 over x. When we cross multiply, the value of x is 1/2. Then let us solve for y. We have here q equals 1 over y. We substitute the value of q here as 3. So we have now 3 equals 1 over y. When we cross multiply, the value of y is 1/3. If we want to know if the answers are correct, we can substitute the x and y values in the original pair of equations. Then we will see that these equations are satisfied. Example 2. Solve the pair of equations 5 over x minus 1 plus 1 over y minus 2 equals 2. Second equation, 6 over x minus 1 minus 3 over y minus 2 equals 1. We factor out the numerator respectively. The first equation becomes 5 times 1 over x minus 1 plus no change in the fraction with y variable equals 2. Second equation, 6 times 1 over x minus 1 minus 3 times the fraction 1 over y minus 2 equals 1. Then we let p equals 1 over x minus 1 and q equals 1 over y minus 2. The two equations becomes 5p plus q equals 2. Second equation, 6p minus 3q equals 1. So this is first equation, second equation. We will now solve using any method. Let's say we solve by substitution. From equation 1, we have q equals 2 minus 5p. Let this be equation 3. Then we substitute this q value to equation 2. Equation 2 is 6p minus 3q equals 1. So it becomes 6p minus 3 times the quantity, 2 minus 5p equals 1. Simplifying the left side, it becomes 6p minus 6 plus 15p. From here, we can combine the 6p and the positive 15p. This negative 6 we will transpose to the right. So it becomes 21p on the left equals 1 plus 6. And the right side becomes 7. Now let us divide by 21 and simplify. We will get the value of p as 1/3. Next, we substitute this p value to equation 3. This is our equation 3. Q equals 2 minus 5p. It becomes q equals 2 minus 5 times 1/3. We multiply 5 by 1/3. We have 2 minus 5 over 3. We can show that this 2 as a whole number can be written as a fraction with same denominator. So the value of 2 becomes 6 over 3. So we can now subtract the two fractions. 6 minus 5 is 1 all over 3. The value of q is 1/3. We are able to get the values of p and q respectively, but we need the values of x and y. In the beginning, we said that p equals 1 over x minus 1 and q equals 1 over y minus 2. We can now solve for x and y respectively using the values of p and q. Let's begin with this p equals 1 over x minus 1. When we substitute the value of p as 1/3, it becomes like this. 1/3 equals 1 over x minus 1. When we cross multiply, it becomes x minus 1 equals 3. Then this negative 1 we transpose to the right. It combines with the positive 3 on the right. So we have x equals 4. Then let us solve for y. Q equals 1 over y minus 2. We substitute the value of q in here. It becomes 1/3 equals 1 over y minus 2. When we cross multiply, y minus 2 equals 3. Then this negative 2 we transpose to the right to be combined with positive 3. Value of y equals 5. So the values for x and y are 4 and 5 respectively. If we want to check if these answers are correct, we substitute these values in our original equations, and we will see that these are satisfied. Example 3. A boat goes 30 kilometers upstream and 44 kilometers downstream in 10 hours. In 13 hours, it can go 40 kilometers upstream and 55 kilometers downstream. Determine the speed of the stream and that of the boat in still water. We let x equals the speed of boat in still water. We let y be the speed of the stream. Also, the x plus y is the speed of the boat downstream, while x minus y is the speed of the boat upstream. Also, remember that time equals distance over speed. If we analyze our problem here, this is a combination of upstream and downstream with respect to time. In the first condition, 10 hours. Second condition, 13 hours. Now, for the first condition, we have this t sub 1 or time 1 plus t sub 2 or time 2 equals the total 10 hours. So we write 30 over x minus y, this is for the upstream, plus 44 over x plus y, this is downstream, equals 10. Condition 2, 40 over x minus y, this is upstream, plus 55 over x plus y, this is the time for downstream, equals total of 13 hours. Next step, we're going to factor out the numerators. The first equation becomes 30 times 1 over x minus y plus 44 times 1 over x plus y equals 10. Second equation, 40 times 1 over x minus y plus 55 times 1 over x plus y equals 13. Then we let u equals 1 over x minus y and v equals 1 over x plus y. Thus, the first equation becomes 30u plus 44v equals 10. Second equation, 40u plus 55v equals 13. And from here, we can solve using any method. In this case, we can use the cross multiplication method. If that is the case, we're going to rearrange the equations again. The right side must be 0 respectively. So the two equations becomes like this. Then we will use our formula and we will substitute the corresponding values. So it becomes like this. U over 44 times negative 13 minus the product 55 times negative 10 equals the V over 40 times negative 10 minus the product 30 times negative 13 equals 1 all over 30 times 55 minus 44 times 40. When we simplify the corresponding denominators, it becomes u over negative 22 equals v over negative 10 equals 1 over negative 110. When we solve for u, we equate this fraction by the last fraction. We will get u equals 1 over 5. For v, we equate this fraction by the last fraction. The value of v equals 1 over 11. But still, we need the values of x and y. In the beginning, we said that u equals 1 over x minus y and v equals 1 over x plus y. Let us substitute the value of u in this equation. So we have 1 over 5 equals 1 over x minus y. When we do cross multiplication here, we will get x minus y equals 5. Now, for the v, we will use this equation. We substitute the value of v in here. So we have 1 over 11 equals 1 over x plus y. When we cross multiply, we will get x plus y equals 11. We have here now two equations with variables x and y respectively. Let us now solve the x and y. Suppose we solve by elimination. We can see that the coefficients of variable y are same but opposite sign. In this case, we can add these two equations. When we do that, y variable will be cancelled. And then x plus x will be 2x equals 5 plus 11 is 16. When we divide this by 2, x equals 8. Now, let us solve for y. We can observe that the variable x here have same coefficients with same signs. So we can solve by elimination and we will subtract. X minus x will be cancelled out. This negative y minus y is negative 2y. 5 minus 11 is negative 6. When we divide this equation by negative 2, y equals 3. So we have now the values of x equals 8 and y equals 3. But for the unit of measurement, remember that both the x and y are speed of the boat and the stream respectively. So this 8 will be kilometers per hour, also for the 3 kilometers per hour.